Hello and welcome back to California Geology. I am Dr. Robert Lopez, and today I want to continue on with the development of the San Andreas transform along coastal California. So we've already looked at this diagram before, just to kind of review a little bit. Remember, here we're going 30 million years ago, the East Pacific rise, so seafloor spreading. Note that the Pacific plate is not in contact with North America. And this line with the teeth on it, that's a subduction zone, a convergent margin. And then as we go down here to 20 million years, note that we've already had first contact. Remember, first contact occurred back over here at 28 million years ago. That's when this East Pacific ride made contact with the trench. And then we developed the two triple junctions, the Mendocino and the Rivera triple junctions. And remember, Mendocino is migrating northward, whereas the Rivera triple junction sort of kind of stalled, but it did migrate southward. In fact, if you read a handout I'm going to provide for you, about 12 million years ago, the Rivera junction jumped south. And so that jump south basically is going to capture Baja California over here, and then is going to make it part of the Pacific plate, right? And so here they have it at 10 million years, so maybe between 12 and 10, but you'll see how it's going to work. Now, the other important thing is note that the San Andreas transform is offshore Los Angeles here, and then also here. And so this kind of scenario continued all the way till about 4 million years ago, right? Till about 4, where the San Andreas, or at least where the Pacific plate is moving pretty smoothly past California. Pretty smoothly, and note that it's right just a little bit west of Los Angeles here. And then at about 4 million years, it moves eastward to basically, I call this onshore faulting over here. And the onshore faulting resulted in this big bend. And this big bend results in compression. Remember, back here we have a bend called a releasing bend. And so the releasing bend here results in tensional stress. So here we can actually put the word tension here, and tension results in opening a basin, and those are those pull-apart basins. Whereas when we jump to a restraining bend over here, this is compression. So we're going to uplift the coast ranges and also the transverse ranges. And so I'll put compress or there just for abbreviation. So now, so we're going to uplift those mountains. Another important thing to make out is, I'm going to show you a video here in a second, but another thing I want to point out is that there is a distinction between the San Andreas fault and the San Andreas transform. And what's important is the San Andreas fault, well, that's a current position of the San Andreas transform. What I want you to know about the transform margin is basically the plate tectonic margin between North America and the Pacific plate, right? Between North America and the Pacific plate. And note that in the past, that margin was in different places. It was here, it's offshore Los Angeles. Today, it's onshore. So what that means is that the transform is the margin through time, and it can migrate through time, right? It's migrating, and it will change, right? So here the San Andreas, the North American boundary has always been the San Andreas transform, but as we will see, it has changed places through time. The San Andreas fault is the location of the principal transform fault today, right? And there's other faults. There's the Hayward fault, the Calaveras fault. In Southern California, there's the Elsinore fault. So all those take up some motion along. There's also the Eastern Mojave Shear Zone and the Sierra Nevada fault. They take up some of the motion between the North American plate and the Pacific plate. The San Andreas fault proper takes about half of that distance, right, between the two plates. And so that's another important thing to note. So what I want to show you next is this video here. And this is actually by Tanya Otwater, who is at UC Santa Barbara. She developed this video of the Pacific margin going back from about 38 million years ago to present time. What I want you to point out here is that this is the East Pacific rise, right? So the East Pacific rise, seafloor spreading off of California. This line with the teeth on it is the subduction zone, the ocean trench. And this ocean trench, we have the Farallon plate going into that trench, subducting. And note that the Pacific plate is nowhere in contact with North America. Other things to point out is look how skinny California and Nevada are, right? So because during this time, we're seeing compression, subduction, compression. There's no strike slip faulting yet, no San Andreas fault. And also note that Baja is attached to mainland Mexico over here. So we'll run the video here. This black line will move toward the present. So right around 28 million years ago, you're going to see the first contact here. So there's the first contact, and now we have the Juan de Fuca plate and the Cocos plate in the south. Note that the Mendocino triple junction is migrating north there, and now we're moving, so about 10 million years ago now, right around 4, we're moving the San Andreas fault inland, right? So that's our current scenario where this fault used to be offshore and now it's onshore. So we can go back a little bit here. So in here, we have the Juan de Fuca plate in the north and the Cocos plate in the south. And in this region here, we're developing the San Andreas fault. And right around 28 million years ago, where first contact occurs, and that basically is going to cut subduction off over here to the east. And then as we move here, we see now our Mendocino triple junction is really moving quite fast compared to the Rivera junction here, right? So if we see this, the Mendocino is moving north. And then now note that the Pacific plate, it's sliding past North America very smoothly, but it's not moving toward North America. So there's no compression here. It's almost like pulling away or pulling on the edge of North America. And you'll see that California and Nevada start getting wider. And we're going to begin that basin and range extension there, basin and range extension. Now, a few things are going on with the transverse ranges here. We'll talk about this when we do the transverse ranges. But what I want to focus on is what's going on here with Baja. So here, right around 12 million years ago, we're seeing that the fault line is kind of moving around down here. So if you can sort of see in this picture here, the fault line is over here. But if I move a little more, it kind of switches a little bit there. So that's right around 12 million years. So what's happening is the Rivera junction is starting to move to the south. So currently, the Rivera junction is at the mouth of the Gulf of California. And so it's going to eventually move down there. So if we kind of keep moving here, right there. So now, right here around 5-6 million years ago, that Rivera junction is now down here. So you see there's some subduction going on under Mexico here, but all this becomes the East Pacific Rise, which is right in here, and then it turns into the San Andreas Fault right here. So that's happening around 4 million years ago, where it really gets set up right in there. And so now that's where we went from a releasing bend to a restraining bend. So in fact, let's watch the whole video one more time. And then, in fact, I'm going to put this video up on our Angel site as well. So there we go. Now we develop Mendocino junctions moving, and let's watch Nevada and California sort of stretch out. There they go, stretching out, basin and range extension, and there we are, the current margin of California right there. So in the little article I wanted to read about that accompanies this video, they talk about how the faulting has occurred in really 3 steps. The first step is offshore faulting. The second step is where we capture Baja California and we have this onshore faulting. And in the future, there's going to be another step where we're going to capture the Central Valley, and the Sierra Nevada blocks will eventually become part of the Pacific Plate. So Tanya Hotwater has also made a video that goes about 10 million years into the future. So here we are today, and we're going to go 10 million years, or here's today, we're going to go 10 million years into the future. So let's run this, see what happens here. Well, in fact, so let's start it again here. So in this case, note that this is our current configuration at 0. And so here's, note that we have the San Andreas, the big bend in the San Andreas here, San Andreas Fault. And as we move it, right there, right around in maybe 2 or 3 million years in the future, we start seeing more intense faulting out here east of the Sierra Nevada. And then the San Andreas transform migrates inland, and now California gets broken up, and it's becoming a microplate moving northward, right? We still see subduction up here in Oregon and Washington states, but there's no more subduction into California, which means our Cascades, Shasta and Lassen, will not have a magma source. Okay, well, let's stop here for now.